Euclid did a lot of things for shapes and triangles, but this one is probably not the most well known. Took a triangle and did an angle bisector with the point A. We're going to look at this case first. Took an angle bisector, and when he split it up, he noticed that the ratio of AB to AC equaled the ratio from BP to CP. So 1 to 2 as 3 is to 4 is essentially what they did. So, okay, so you split this triangle, you just do an angle bisector. How is that going to make that ratio? Well, I'm going to employ something from, maybe not expecting this, but we're going to use the law of sines to do this. And so would you write this with me right on the screen? I drew this top triangle and I split it up into two. It's an angle bisector, so both these angles are alpha. That's going to be the key. We're going to call this angle here beta. Can you tell me what this angle here will be? 180 minus beta. Now that's the key to this thing working, is that on the unit circle, what can you tell me about the sine of beta and the sine of 180 minus beta? What can you tell me about the sine of beta and the sine of 180 minus beta? What can you tell me? They're the same. That's how this is going to work. Okay, so let's do it. We're going to go, and I'm going to make sure I do the right values here. I'm going to take, we're going to do the law of sines here. So it's going to be alpha sine, well, let's do it this way. BP over the sine of alpha, BP over the sine of alpha is going to be equal to BA over the sine of beta. Do you agree with that? Okay, now I'm going to, over here, I'm going to say this is going to be PC over the sine of alpha is equal to AC over the sine of 180 minus beta. Now, what did I say about the sine of 180 minus beta? What's that equal to? Sine of 180 minus beta. That's equal to the sine of beta. Because it has the same y value, the sines are going to be the same. So this can be converted into PC over sine of alpha. Well, I'm going to restructure this. I'm going to switch these two. PC over AC equals sine alpha over the sine of beta. And this one, I'm going to do the same thing. I'm going to go BP over BA is equal to the sine of alpha over the sine of beta. Notice that I have these two sine of alpha over sine of betas. What does that tell us? Anybody? What does that tell us? If these two are equal, BP over BA is equal to PC over AC. Now I want to look here. I have AB over AC. Okay, so they switched these. So they had AB over AC equals BP over PC. And that is, yep, that's what we wanted. That's the relationship. So AB is to AC as PC for AB is to AC as BP is to PC. So that relationship, think of it this way. I remember doing this last year. Take your hands, make a triangle, okay, break them apart. This over this equals this over this. You got it. This over this equals this over this. That's for your triangle. Now that part you get, and it goes pretty well. The one that doesn't go as well is this external one. But through the magic of the law of sines, you're going to be able to do this. So do this one with me and find a space. Do this one with me, please. What we're going to do is we're going to break this into two triangles. Now here we have AB is to AC as BP is to CP. So essentially what we have are two triangles. We have this one, which is ABC, and then we have the whole triangle, which is A, B, and P. All right, so let's check these out. So this one here, we have, there's a bisector, but the edge is AP this time. So AP is shared by both of these, just like it was shared by these two triangles originally. This AP is shared here. It's broken into two equal angles, alpha and alpha. It's just that the alpha here is an external angle to AB. Okay, so what we'll do, this angle here is going to be out here is alpha. This angle is alpha. These two are alpha. What's this angle here? This is a straight line. 180 minus alpha. Would you write that down? Because we're ready now. This angle is beta, and this angle is beta, because P is the same. We're going to use the law of sines again. And now all should be well with the world. We have BP over the sine of 180 minus alpha should be equal to AB over the sine of beta. For here, we're going to have CP over the sine of alpha equals AC over the sine of beta. Do my little trick where I put those together. We're going to have BP over AB equals the sine of 180 minus beta over the sine, or alpha, I mean, over the sine of beta. And then here we're going to have CP over AC equals sine alpha over sine beta. What did I say, though, for the unit circle? If I want to take 180 minus alpha, what's true about the sine? If this is alpha now, what's true about the sine of alpha and sine of 180 minus alpha? They're the same. So this just gives us sine of alpha over sine of beta. These are the same. So therefore, you can say BP over AB equals CP over AC. And that's going to translate into my grand finale. I want AB over AC equals BP over CP. Same relationship. And those are the proofs for this. This one's a little harder to visualize. Just think about what's in the middle. AP is in the middle. So for the first one, we did with your fingers, we had the outside ratio to those thumb ratios. For this one, now what you're going to do is you're going to have the still AB to BC, AB to BC, but then you're going to have the other one is going to be AC to the whole BC. or CP. So it's a little bit different, but it kind of works. The classic proof, you can look at that. I like that one too, but I like the law of sines a lot better. The converse is if you have this relationship, then you can prove that the angle bisects. So, and they use the same thing that we just did, but in reverse. So there's no sense to prove that again. For the examples here, we're going to just do this AB over AC. So we do 8 is to 11 as 3 is to x. 8 is to 11, 3 is to x. And so 8x equals 33, you get x is equal to 33/8. So that's fine. And now we're going to do the same thing, except we're going to use this other one. With the external areas, you're going to do QR to QS. So 3 is to 9, or 13 is to 9. This one is to here. And then what you're going to use for the bases is you're going to use this whole, because this is from the whole, 11 plus x over this shorter part, which is 11. So think of it this way. You have 13 is to 9. Those are the lengths, kind of like the outside, except it's the middle this time. And then you're going to go from the whole to the short, 11 plus x. And then you can do the algebra for that. I don't need to. They've got it all worked out here. You'll get 44/9. Okay, so I'm going to have you try 2A and B as a group, see if we can do this before you leave today. And that's it for the video.